Okay, so we've been talking all along here about the scientific method as this ongoing process, and we've talked about how to ask questions and form hypotheses and get data. But our next step is then that we have to analyze the results. And there are a lot of different techniques that you can use in psychological research to analyze results. A lot depends on what kind of data you've collected in the first place and what your hypothesis is. But in this course, what we're going to be concerned about is looking at measures of central tendency and correlations. So when we talk about measures of central tendency, that's the first one, we're really talking just about what an average is. But this word can be confusing because the word average can really have two different meanings. One is the mathematical average, where you add up all of your scores and then divide by the number of scores. But average can also just mean typical. And so when we have here three measures of central tendency, they are all ways to describe kind of what is typical of a set of data. So there are three types. The first one is what's called the mean, and this is the mathematical average. So you take all of your scores, you add them up, and you divide by the number of scores. And that's usually what people are talking about when they talk about an average. They usually mean the mean. But we can also talk about the median, which is where you line up all your scores from lowest to highest, and you just take the one in the middle, regardless of how much it resembles the one around it. And then there's the mode, which is just the most frequent score. So for example, in that list of numbers I gave you, the mode would be 1 because it's the most common score. And sometimes, depending on what the data looks like, sometimes the mean, median, and mode will all be the same or very, very similar. But sometimes they aren't. And so it can become very important to decide which one to use. So I'm going to give you here some numbers of a company that I just completely made up. So imagine we have this company that has 7 employees. 3 people who earn very low salaries, $10,000 a year. 3 people, maybe they're like middle management, they earn 40, 50, and 60,000. And then we have maybe a very well-paid CEO who earns 900,000 a year. Well, if I were to take the mean, right, so I add up all of these scores and then divide by 7 because there are 7 scores, I would get a mean of about $154,000 a year, whereas the median in the middle is 40,000 and the mode is 10,000. Well, which average I pick depends on what I think of the company. If I want to make the company look great, I'm like, our average employee makes $154,000 a year. And technically that's not lying, but of course it's really very misleading because nobody makes that amount of money. So between the other two numbers, the 40,000 and the 10,000, we could debate which one is more appropriate for describing the typical employee at this company. But either way, we could all agree that 154,000 is definitely going to be a misleading figure, even if it is not technically a lie. So that's measures of central tendency. The other type of statistics that you need to be able to interpret in this course is you need to understand how to interpret a correlation. Okay, all right, and all three of these can be called averages. I said that. So the thing to know about a correlation coefficient is, first of all, that it is expressed as a number. It can range anywhere from -1 to +1. The only way to get a number outside that range is a math error. And when we look at the correlation coefficient, we need to know two things. The first is its strength, and that's determined by how far away from 0 it is. Right? So 0 means no correlation. This is like your IQ and the length of your pinky toenail. There's just no relationship. The farther you get in either direction, the stronger it is. So -0.8 is going to be a lot stronger than, say, +0.2. So that tells us how strong the relationship is. The other thing to know is the sign is the correlation positive or negative. And this tells us the direction of the relationship between one variable and the other variable. So on the next slide, I'm going to show you kind of your two options, positive and negative correlations. Okay, so positive correlation is on the left. And it simply means that when values of one variable increase, values of the other also tend to increase. So the example they've given here is that people who have more years of education tend to have higher incomes. Okay, now this is not a perfect relationship, right? You might have someone who is a high school dropout and makes a ton of money, or has a PhD and doesn't make much. But generally speaking, there's going to be a positive relationship. We would see a positive correlation, say, between people's height and their shoe size, or the number of shots of vodka they do before an exam and the number of mistakes they make. Not something I recommend trying, but it would be a positive correlation. A negative correlation is the trickier one. Okay, and what's important to keep in mind here is that positive and negative are just math terms. This has nothing to do with good and bad. It's all just about math. So in a negative correlation, as values of one variable increase, the other tends to go down. So people who have less money tend to have more dental problems. People who skip more classes tend to have lower course grades. Okay, so we're not necessarily saying if there's a cause and effect, but just that there is a statistical relationship here. And we've talked about this before in class, this idea that correlation does not necessarily mean causation. Okay. So the fact is, whenever we have two variables, we actually have three possibilities. And so the example I'm going to use here is low income and the number of years that a person spends in prison. So if we call these variables A and B, our first option is that A causes B. Low income makes you go to prison. Okay, well, in this case, we know that actually makes no sense, right? If I take away all your money, you won't be happy, but you're not going to go to prison for it. Our second option is that B causes A, and that one actually now makes sense. People in prison don't have jobs. It makes sense that their income would decline. But we also have to always look for the possibility of a third variable. So this is something that's going to relate to both A and B and is going to explain the relationship between them. So in the case of why low-income individuals would spend more time in prison, there are a ton of possible variables here. So one possibility might be intelligence. Someone who is very low might have trouble holding a very low in intelligence, might have trouble holding a high-paying job. They also might be more likely to get caught when they do commit a crime, and so they're more likely to get sentenced. We could look at race. We know that in this country, that all other things being equal, non-white individuals are more likely to be arrested for certain crimes, charged. They tend to get harsher sentences. So we can look at things like jury bias, police bias, and so on. We could look at impulse control. So someone who really has trouble reining in their temper, they're going to have trouble holding on to steady jobs, and they're more likely to do impulsive things that wind them up in prison. So, and there are a lot of others as well. These are not the only three. But the idea here is that we could have a relationship between low income and years in prison without one necessarily having to cause the other. Now, there are other possibilities here. So we have to also keep in mind that it could be illusory. It could be that two things have a statistical relationship and it's just a coincidence. So the chart I'm going to show you here, this is if we look at people who sometimes wonder about whether dreams predict the future. Right? So someone says, oh my gosh, I dreamed about Aunt Mildred and then she died. But here's the thing. Most of the time, on any given day, you're not going to dream about Aunt Mildred and she's not going to die. But nobody notices this. They're just like, okay. They're going, oh my god, I dreamed about her and she's still alive. Whoa. They're just not going to notice. Same thing, if they dream about her and she doesn't die, they might think it's a little weird, but it's not going to really come to their attention. They're not going to give it a whole lot of thought. If she dies and they didn't dream about it, they're going to be sad, but people aren't going to be like, whoa, she died and I didn't even dream about it. Who would have thought? So it's not going to strike them. But on that rare occasion where someone dreams about Aunt Mildred and she dies, now this is going to get their attention and they're going to really think that there is a stronger correlation between dreams and death than there really was. And again, like I said, it could also just be a complete coincidence. So this website, you can see here, tylervigan.com. He's got a whole site where he just thinks it's hilarious to look at things that are statistically related that really have nothing to do with each other. So this is 9 years worth of data. Divorce rate in Maine turns out matches up very well with per capita consumption of margarine. It's possible there's a real relationship, but most likely we're talking complete coincidence here. So that's it. If you have any questions, please email me or give me a call. And in the meantime, I hope you all have a wonderful day.